When you read this question, if you think the direction of the change in velocity is northeast, you better stick around because I'm going to get you an extra mark. So there's two steps to this. Number one, find the direction and magnitude of the change in velocity, and then divide that by the time taken to find your acceleration. So let's go with step one, finding the change in velocity. Now, when my students do vector subtraction, I always get them to draw three vectors: the initial velocity, the final velocity, and the initial velocity flipped. Change in velocity, or change in anything, is just the final of that quantity minus the initial of that quantity. So change in velocity is therefore final velocity minus initial velocity. So I always get my students to rewrite the equation as final plus the negative of the initial. Then hopefully that gives you a little snap kick to the head and you recognize I need to flip my initial velocity vector. So let's draw up those three vectors. So now we have our three vectors, the final, the initial, and the negative of the initial. To be honest, we only need two of the three, but I always get my students to draw all three, just so they know if they draw three vectors, then they're on the way to solving the problem. So these are the two vectors we're going to use, the final and the negative of the initial. Now let's do our vector sum. Little pro tip here, if any of your vectors are already perfectly north and south, draw those vectors first, because when you measure the angle, it's then from the north-south axis, which is usually what the teachers want. So now we've got our two individual vectors summed together via that tip to tail vector addition. So we've got our 20 being our negative u, we've got our 20 towards the east being our v. Now we've just got to basically do Pythagoras and arctan. It's 28.3, isn't it? 28.28, 28.28 it is. We then use Pythagoras to find the magnitude of our change in velocity vector. We then use arctan to find the angle relative to the north-south axis. Okay, and as you can see, the angle comes out to be exactly 45 degrees. So we end up with our change in velocity is 28 meters per second south, 45 degrees east. So remember, we use Pythagoras to find the magnitude, arctan to find the angle, but then you bring the two things together and you make the angle mean something. It's got to be measured relative to something. And this is where you really need to know what your teacher wants. Some teachers will insist on following sig fig rules throughout the entire question. Other teachers want you to round at the very, very, very end. So ask your teacher, what do they want? Because in this question, it actually will impact your final answer just a little bit. So if we carry on the 28 from the previous part of the question, we get our acceleration is about 5.6 ms to the minus 2. But if we carry over the 28.3, it actually comes out to be 5.7 ms to the minus 2 to 2 sig fig. Just keep in mind, when you divide the change in velocity by time, you're just dividing through by some number. It does not change the direction of the vector. Easy peasy, one extra mark. Please make sure you flip the initial velocity vector if you're ever finding change in velocity or acceleration.